Good evening, everyone. My name is Samuel Ranamwanda. I am the editorial assistant at the Journal of Kenya Association of Physicians. I want to welcome you to a practical approach to inferential statistics. This is the continuation of the previous lesson session we had last week, that is pertaining the inferential statistics that we are guided by Dr. Isaac. Today now we are doing a practical approach of the theory part that he explained to us. I want to welcome you to our 12th section as we discuss this amazing topic. First of all, allow me to introduce you to the objectives of our today's session. I want us to go through the objectives and what things we want to achieve by the end of this session. First of all, I want us to, because earlier Dr. Isaac introduced us to a lot of theoretical part of these tests that are conducted in inferential statistics. I want just to say a few things pertaining these parts before now I dive into the practical part of it. First of all, allow me to introduce you to the pair and t-tests. And Dr. Isaac actually explained a lot pertaining the pair and t-tests. In the previous session, we were told that a pair and t-test is a statistical method used to compare the means of two related groups to determine whether there's a statistical significant difference between them. And actually, before we start conducting the analysis, especially for pair and t-test, independent t-test, or any other analysis, especially pertaining the parametric data, first of all, we were told about the normality. First of all, we'll have to check the normality of our data that you are going to use for analysis. So we were told that when to use a pair and t-test is when you want to compare, let's say, for example, before and after measurement of the same subject. Let's say, for example, weight before and after diet, or for example, you want to measure from the same individual and under two different conditions. Let's say, for example, suppose you are testing maybe a new teaching method and you reckon the test scores between before and after using it on, let's say, a same group of students. Let's say you want to compare the teaching methods. So here now you will have to apply the pair and t-test so that you can compare the performance of these different groups. Another test we are going to conduct is an independent t-test. An independent t-test, also we talked about an independent t-test whereby we said that an independent t-test is a statistical test used to compare the means of two independent groups to see if there's difference between them is statistically significant. Also, we were told that when we use it when you have two separate groups, let's say, for example, male versus female. Let's say, for example, in our data, we'll have a drug and a placebo. This is where now we'll apply an independent t-test. Also, the data that you are going to use, you have to have a continuous dependent variables. Let's say, for example, the test score and the blood pressure. Also, we can check about the categorical independent variables. Let's say, for example, group A versus group B. So under the independent t-test, what do we want to know about it? So first of all, before you conduct an independent t-test, you have to check for the normality of the data that you are going to use. After that, also we'll have to conduct another analysis that is for ANOVA. We'll also do we check the trends across multiple time points. Also, you'll have to check multiple regressions, logistic regression, chi-square. Also, a chi-square is used when you want to examine the relationship between two categorical variables. Like, let's say, for example, like gender and preference, or education level and the job let's say job type. Also that one we'll have to conduct a chi-square and check. So after that, also we'll conduct a mixed effect models. Also to that one we check on advanced handling or repeated measures. So allow me to introduce you to our practical example, the one that you are going to use. In our practical example is just a control study that this one is a control study that I'm trying to do. Let's say, for example, study. It's a study design between a placebo and a drug. So whereby I included one of the participants so that because when you are conducting especially this analysis or regressions, especially in inferential science, you're supposed to have a large data that is able to cope in to conduct this analysis. So in our analysis, we have a placebo group that is have 75 participants, and the drug group that have also 75 participants. So in my study, I wanted to check the hypothesis, and I explained my hypothesis that the primary hypothesis was that the drug achieved greater HbA1c reduction, that is, than the placebo. Also, the secondary hypothesis, I want to check whether both groups improve over time. More drug patients achieve HbA1c that is less than 7%. So the methods that we using for our studies that we have got 150 patient, that is 75 on the drug and 75 placebo. The follow-up, we have the baseline. The baseline, when I talk of baseline, I say under the baseline, that is the first time when the patient reported in the clinic. That is the first day for the trial. The patient HbA1c was recorded, and it was the first recording. That's what we call the baseline. We have talked under my data. We have a baseline of the HbA1c. We have a baseline of weight and blood pressure. Also, that later the HbA1c was recorded after 3 months and also after 6 months. So all that data falls under the follow-up, and all the data have been recorded in our SPSS. So all these data that have been collected, we'll have to conduct an analysis, that is the t-test analysis, the ANOVA, the chi-square, and the regression, and the ANCOVA. That is analysis for covariances. So the next also this one is the variables that you have, the continuous variables, we have HbA1c, we have the weight, the systolic, the BP, the categorical variables, that is the HbA1c, that is less than 7%. This one we have to record in SPSS so that we can categorize it either yes or no. Other thing is the composite for success, that is yes or no. The predictors, we have age, sex, adherence score, lifestyle score, and the measurement at baseline I've already explained. So the first question that you are supposed to ask yourself, the questions that we are going to ask ourselves during our analysis is whether did the HbA1c improve over time? That is one of the key questions that we want to answer through our analysis. And that's what we want to know, whether the HbA1c improved over time. Also, we want to answer another question, whether was the improvement greater in drug group or in the drug group. Also, that's another question we want to answer in our study. Another question that we want to answer in our analysis is what about the weight and blood pressure? I think about the weight and the blood pressure, also the same analysis will be done as this one for drug group. Also, we want to answer a question on whether did more patients reach treatment targets. That is by the end of the 6th month, did the patient who are under the drug, did their HbA1c increase or it increased? That is to compare whether those under drug, the drug was active or was it the placebo. So that's where we want to see, we'll do this, we'll advance on this question on whether the patient reached the treatment targets. Another question that also will be answering is which factors predicted better outcomes? Which factors facilitated the increase in HbA1c? Is it the weight? Is it the height? Is it the weight? Is it the blood pressure? Also, that question will be answered in our analysis. The last question that we'll advance in our analysis is on whether the intervention remains significant after adjustment. So also that another question we'll have to answer on our analysis. So let's get to our analysis, and I will have to be conducting for each and every question. For the HbA1c improvement over time, we'll have to conduct a P&T test, that is a repeated measure ANOVA to check on whether the HbA1c improvement over time was noted. Also, the group difference, that is in HbA1c, that is the difference in the placebo and the drug. Also, we'll have to conduct an independent t-test. Also, we'll check on the weight and the BP outcomes, that is same test as HbA1c. We'll conduct the same test, that is the independent t-test. Also, we'll have to conduct a proportional reaching treatment targets, that is a chi-square test, that is oral, which also follows up with the Fisher exact test. And the predictors of success, also we'll have to conduct a logistic regression. That is to check whether the HbA1c less than 7% was achieved among the patient who under the drug or the placebo. We want to check whether the success or what we want them to achieve after 6 months was achieved. We'll have to conduct a logistic regression. Also, we want to check whether the factors that, let's say, for example, gender, age, weight, and other factors, and a contribution, especially on the increase in HbA1c. We'll have to conduct a multiple regression analysis. We'll check whether there is any effect that let's say, for example, the weight, the blood pressure, or any other factor, the age, and an effect on the increase of HbA1c. Also, we'll check on the overall time and group effect. That one we also do a repeated ANOVA, repeated measures of ANOVA. Allow me to, first of all, now we dive into step by step. Allow me now to partition my screen so that we can be together as we go through the analysis. So when you check on the left side of my screen, I have just partitioned on my screen so that we can be able to go step by step. In the previous session, we were introduced on how to import our data in SPSS and how to conduct data in SPSS. I think I will not go back to that because we were taught on how to import our data, especially from, let's say, for example, the Excel or somewhere you have recorded your data to SPSS. Now I'll go directly to analyzing our data that we have already imported in our SPSS. My data, when you see the data that I have that is with me already, we have a patient ID, that is the patient who attended the standing. We have the score, the gender, we have the gender, we have the age of the patient, also the age of the patient was recorded. Also, you can see the HbA1c baseline. The HbA1c baseline is the HbA1c of the patient that was recorded the first day he came in the clinic. So, for example, a patient came in the clinic today and his or her HbA1c is taken, let's say, for example, it recorded at 6.59. So the HbA1c is the at baseline is the data that was recorded in the first day the patient came in the clinic. Then we get to the HbA1c 3M. 3M means after 3 months. So the patient came after 3 months to conduct that test again. So the test was conducted after 3 months and it was recorded. Also, the patient came after another 3 months. That is for the 6th time. For the 3rd time, that is 6 months. That is where I've recorded 6M. So the HbA1c also was conducted at that time. So also it was recorded. The weight the same time was recorded in the first visit, the second visit, and the 3rd visit. Same to the blood pressure, that is the blood pressure was recorded in the baseline, that is the first visit, second visit, and third visit. Our visits are our visits have there are three visits. That is the baseline first visit. The second visit came after 3 months, and the third visit was after 6 months. All that have been recorded in our data, as you can see. So our control, that is the control and the placebo, we have the drug and the placebo. I have used black because my SPSS was not allow me to have the whole one written here. So allow me now to get into, first of all, we are supposed to test for the normality of the data that we are going to analyze. First of all, the data that you are going to use, especially the HbA1c, let us check the normality of the data. I think last time we were taught on how to check the normality of the data. So when you want to check the normality of the data, we are told you, I think everyone can see from the left side of my screen. So first of all, you come to analyze. You come to analyze. You want to check for the normality of the data. Which data do you want to check the normality? So you come to explore. You come to descriptive statistics. You want to explore your data. Oh, sorry. So we want to explore our data mostly because we'll be using. So I want to explore the HbA1c at baseline, 3 months and 6 months. I want to know whether the data was normal and distributed. The data was collected was normal and distributed, so that we know that this data fits for the analysis that you are going to conduct, especially the data that the analysis that the parametric analysis that you are going to conduct. So I have to load my data in the dependent list. That is the HbA1c baseline, the HbA1c in 3 months, and the HbA1c in 6 months. So I go to statistics, that is descriptive, go to plots. I want to check through the histogram. The histogram, you mark the histogram and the normality plots with tests. So you continue. Then you press display. It's all you check both the statistics and the plots. Then you run and OK. So after running that, I think Dr. we were explained about the case processing summary. That includes the number of the sample, the percent, the missing data, the percentage error, and this one or this. So the most important thing that we wanted to check is to check the normality. So we want first of all we want to check whether the HbA1c baseline at the baseline, whether it was normal and distributed. So first of all, I want to bring in a distribution curve. So you come to elements. You come to distribution curve. You choose it. So you come here. It's normal. So I think you can see our data is normally distributed. We say that data is normally distributed when it shows a bell-shaped curve. You can see this one is a bell-shaped curve, and the mean is usually at the center. Like you can see our mean lies at the center, like 7.99. So that means our data that was collected in the first visit of the patient is normally distributed. Let's also go and check for. I love to use the histogram because they are somehow simple to understand. So also let's check on our HbA1c that recording that were taken 3 months. So you fit show the distribution curve. Yes. So you can close this. So you can see even this one, you can see the HB1C that was taken. The recordings were taken after 3 months also. They are normally distributed from our when you check on the histogram. That is, they have a bell shaped and the mean lies at the middle. Also the outliers, you can see the way outliers are distributed. So the last one, let's check the HB1C in 6 months, whether it is normally distributed. So the histogram, this is for HB1C 6 months. Sorry. So let's now bring in the distribution curve and check. So after bringing in the distribution curve, you can see also it shows that the data was normal in distribution because it shows umbrella-shaped curve. So our data is well, it's good now to perform, you can close this one. We can now perform a pair t-test for our data because it is normally distributed. So now we can go step by step now to conducting let's start by inferential statistics. Let me enlarge this one so that I think it's visible. So let's now go step by step to conduct an inferential analysis, especially starting with the pair and t-test. The pair and t-test is whereby we want to compare the analysis within groups. Like in our case, we want to compare the baseline versus 6 months, that is the HB1C in the groups. So first of all, when you want to analyze the pair and t-test, I think this screen is enough. Someone, you can tell me whether this screen is enough for SPSS so that everyone can understand the steps that we are using. So when you want to analyze now for the pair and t-test, first of all, you will come to analyze. You will come here to analyze. When you come to analyze, you will come to compare mean. After coming to comparing the mean, we want to do a pair and t-test. This is the pair and t-test you want to conduct. Sorry for that. So you come to analyze, compare mean, pair and t-test. So sorry, I unloaded this one. Let me remove this one. So in our data, what are we comparing? So for our case, we want to compare the baseline versus, let's say we want to compare the baseline versus 6 months and also the baseline versus 3 months. So I will have to load all the data. So the pair that I want to compare is, first of all, I want to compare the baseline. The data that was taken the first time the patient arrived in the clinic, and after six months, I want to compare and see. Also, I want to compare baseline and 3 months. That's the data I want to compare for the patient. So I think you are following on the other parts, on the other side. So first of all, you open SPSS. Those who are having SPSS you can open them. You go to analyze, compare mean, you get to parent sample t-test. Then you load what you want to compare. You want to compare the HB1C. That is the first time the patient came in the clinic. You load it. You load the HB1C in 3 months. And then you go back. You load the HB1C the first time the patient came. Then you load the 3 months. So that's the data we want to compare in this analysis. So after that, you press an OK so that the SPSS can analyze your data. So after pressing that, you can see the output, what I have been given, what the SPSS have analyzed for me. So the paired sample statistics just tells something about the mean. We have the standard deviation, that is the declaration of the standard error. We have also the pair and sample correlations is here. So the most important part in our analysis is the paired t-test. So this is the part whereby we want to compare the first pair and the second pair. The first pair contains the HB1C recording baseline and the HB1C recording in 6 months. And also we have pair 2, which contains the HB1C recording in the first time and after 3 months. So we have the mean, the standard deviation, the standard error, mean and 95 confidence interval. So, and the upper bound and the lower, we have the t statistics, the degree of freedom and the significance. So this one now is what we wanted now to interpret after we have now obtained this is the most part that you have to bring in your data analysis now. So in interpretation, what interpretation will you be doing for this one? So the HB1C values at different time points, that is at the baseline, 3 months and 6 months, within the same group of 150 patients with a degree freedom of 149. The degree of freedom is 149 because in statistics, in rules of statistics, we say that n, which is 150 minus 1, that's where we obtain the degree of freedom as 149. So here the HB1C at pair 1, we see the mean difference is 0.8. Sorry, a 0.8, and the other one and this one is for pair 2 is 0.58, 0.58837. So that means the baseline is higher than 3M, that is in 3 months. So what conclusion do we have to make about the interpretation of our table? The interpretation of our table tells us that HB1C dropped significantly from baseline to 6 months, even larger. So from our statistics, you can see the HB1C when it was conducted in 6 months, it dropped. So from baseline compared to 3 months, it dropped. And also when you compare the baseline and the 6 months, it dropped. It also dropped. It dropped further compared to 3 months. So the true mean addition reduction in both is you can see is around 0.33%. So the interpretation here is that HB1C continued to drop between 3 months and 6 months. That is what we can conclude from our table. So from our analysis, you can conclude that the HB1C dropped in 3 months and in 6 months. So we get now to when we conduct that one, what conclusion will you be making, especially the overall conclusion that we'll be making. The overall conclusion that we'll be making about the HB1C is that the HB1C statistically decreased from baseline. That is from baseline to 3 months and further decreased by 6 months. The reduction has statistical significance at stages because the p-value is less than 0.001. So clinically, we can suggest that the drug under progressive improvement than the control over time. So we can do another analysis. So to get now to compare each group, that is the drug and the placebo. Now we'll have to go down to do another analysis. That is whereby now we'll go down to do the independent t-test so that we can see how the decrease was, how the HB1C in 6 months and in 3 months and in 6 months went in groups. That is in placebo and in the drug. So let me now let me close this analysis. So now we'll go to another step now of doing now let me do now an independent t-test. So when you want to conduct an independent t-test, we want to check how did the HB1C decrease in groups. That is in the placebo and the drug. So we want to compare the H1B1C change between the drug and the placebo. So let me now show you how to, I think you can see how to go by the independent. So first of all, the independent t-test, you have to have the HB1C change that in baseline. We'll have to compare from baseline to 6 months. Also, you'll have to compare from that is from baseline to 3 months. So to analyze this, first of all, you come to analyze. You get to compare mean. Then you come to independent t-test. So after getting there, you have the test variable. Which variable do we want to test? Our test variable is the HB1C, let's say, for example, in 6 months. What grouping variable, where do we want to test it from? That is the drug and the placebo. Those are the people, the ones which you are working on. So we come here, we learned as our grouping. So under the grouping, we are taught on how to define. So first of all, you define the first one. So the first group is the drug. The second group is the placebo. So in my data, I showed you that I have written a plug because of the string. So then you continue. So then you press. So the confidence interval is 95%. Continue. You press OK. So the SPSS have generated for us independent sample t-test. So this one is not so much important. The most important is the independent sample t-test table. This one is now the table that is most important because it's the one that you'll use in your data. So here you have the HB1C in 6 months. That is the equivariance assumed, the equivariance not assumed. So we will talk about the Levin's test for equality of the variances. So you have the degree of freedom, which is 148. That is 150 minus 2. That is n minus 2. So you have the mean difference. You have the standard deviation. Also, you have the confidence, 95 degrees confidence interval. So we have the lower bound and upper bound. So I want us to interpret this table of the independent sample test that we have ran. So first of all, at 6 months, the drug group at 6 months, the drug group has much lower mean HB1C. That is 6.37% compared to placebo. So that is 7.9. That is 7.9. That is around 7.9%. That means the difference of about 1.59 units. So the Levin's test for equality of variances, F is 0.52 and P, that is the P value is 0.421. This one, the significance. So here, since P is since P is greater than 0.05, we assume equivariances between groups. That's what we assume. There's equivariances between the groups. So next, what do we have to say about this one? So so what we say about this one now is that the equivariance is assumed that assumed row of t-test outputs. Also, we have the row of t-test outputs. Also, at step 3 now, the t-test for equality of means shows that the t, that is the t statistic that is 1 for 8 is equals to -7, -7.42, which shows that the p-value is less than 0.01. So this means that the drug group HB1C is statistically lower than the placebo group, and also the difference is highly significant. That is, the p is less than 0.001. So we are 95% confident that the true difference lies between negative it lies between negative 2.0 and negative 1.2 units. So that's what we are confident of. So in the other ones, we can say that at at 6 months, the patient received the drug and significant lower HB1C compared to those in placebo. So that is 6.37% versus 7.95%. So this suggests that the drug is effective in reducing HB1C compared to placebo. So that is the explanation for this now independent t-test, the independent sample t-test for our analysis that we have done. So we have concluded that at 6 months, patients receiving the drug and significant lower HB1C compared to those on placebo. So we go next to conduct our next analysis that we are going to conduct. Let's close this analysis for now. So the next analysis that we are going to conduct is the repeated, let's skip this for now. Let's go to conducting a chi-square t-test. So to conduct a chi-square t-test, we want to compare the HB1C less than 7% between group. We want to see how many patients achieved, how many patients were able, after the 6 months of the control, how many patients recorded HB1C less than 7%, less than 7. That is from, let's say, for example, we want to say that any patient who have the HB1C recording less than 7 achieved our target that we wanted in our study. So to conduct this one will be done by a chi-square. This one will be answering the question here. So this will be answering the question of the predictor of success, the proportion of reaching treatment targets on whether we reach the treatment target that we were conducting. So to conduct this chi-square test, first of all, we have to record our data. I want us to begin as we record our data so that it can be easy for us to conduct a chi-square test. So to record our data, first of all, let's check on the HB1C on the SPSS. You come to transform. You want to transform your data now. So you want to transform your data. You come to record into different variables. Some SPSS may tell you to new variables. So we want to record our data. So recording our data, you come there. So you come to transform, record. So you want to record your HB1C target, that is in 6 months. So then that the HB1C recording of all patients, of the patients that a minute. Sorry for that. So the HB1C recorded after 6 months, we want to see whether we reach our target, which we wanted after 6 months, whether our patient, the patient HbA1c increased or increased. So first of all, so the HbA1c record in 6 months, you will load it here in numeric variables. So the name, which new name do we want now? We will give it a new name. Let's say HbA1c. Sorry, HbA1c underscore. Let's call it underscore. Let's say, for example, targets. So you can repeat the same way for label because it's want to appear on the SPSS. Sorry. So the HbA1c underscore target. You can say it's let it target those who are less than 7%. So change. So you come to owned value. So when you come to owned value, you come here at the range. So the lowest. So let's the lowest, those patients who have achieved the target, as in those patients who have achieved the target that you wanted, they will fit, let them now be, sorry, will be less than 7, less than, sorry, yes, so the patient who have achieved the lowest will have, let's say, 6.999. So anyone with above, sorry, so 6.99. So this one will, so you come here to new, will be our 1, then you want. So the other range value, low, the highest, anyone with 7 and above, that one is now the highest. They have not reached our target. So we say 7, anyone with 7. So we write it as 0, we add. So lowest drew 6.991, 7 drew highest 0. So this one is to tell SPSS the HbA1c that we recorded after 6 months. Any patient who have less than 7, that is from 6.999 and below, have achieved our target. Any patient who have 7 and above have not achieved our target in our standard. That is the reduction in HbA1c. So you continue. So you press OK. So this one now, the SPSS will tell you that the record of HbA1c already have happened into a target. The execution already have gone through, so we can close this one. So you can go to our data and check whether it have appeared. Sorry. So when you go to the data, you can see the HbA1c target that we have coded have already appeared. So in our variable view, we can see it have appeared here as numeric. So the label is a target. So we can now go to conduct the chi-square-t test. The chi-square test so that we can see the patients, how many patients achieved our target. So now we go, that is the first step, that is creating a binary variable. I think that one is okay, everyone have understood here. So the next we go to analyze. Now we get to analyze. When you go to analyze, you go to descriptive. When you get to descriptive, you go to cross tabs. So under the cross tabs, what on the row I've shown you here, on the row you have to bring in here the group. Our group now is the drug. In my data I have written is a drug and the placebo. So I'm bringing it in the row. The column, I'm bringing now the HbA1c target, the one that we have recorded and decoded. This one now, you bring it in the column. So after that, you come here, you click statistics. What do you want to test? You want to test the chi-square. So you want to run the chi-square. Continue. So you tell it, okay. So you can see now it has run our chi-square successfully. So our output is here now with us for the chi-square. You can see the drug. You can see the drug output. You can see HbA1c target. That is the one that we wanted to get from the data. So from this table, the drug HbA1c target less than 7% cross tabulation. It tells us that in drug, that is this one, the total, that is, for example, 52 out of 75% patients reached the HbA1c target. I think you can understand there. So from this one, you can see this one represent the, as we condemn, this one is the placebo, this one is the drug. So 0 to represent the placebo, 1 to represent the drug. So you can see that 52% out of 75 patients achieved or reached the HbA1c target. Here also you can see 14 out of 75 patients reached the placebo, in the placebo also reached the HbA1c target. So when you go now to the chi-square, the chi-square test, the Passion chi-square is 39.07 when you round off this 9 with a degree of freedom of 1. The Fisher's exact test also, the p value, the significance is less than 0.001. So that means there's a significance different in proportion. So in interpretation of this analysis now that we have conducted here, we say at 6 months, significantly more patients in drug group achieved HbA1c that is less than 7% compared to placebo, that is patient in those under the control. That is also you can observe here when you say 52 out of 75, and this one now 61 out of 14 out of 75. So you can confidently say that at 6 months, significantly more patients in the drug group achieved HbA1c that is less than 7%, that is less than 7 compared to placebo. This means that the drug sustainably increased the likelihood of patients reaching the glycemic targets. So in our analysis, we can now conclude that the drug increased the likelihood of patients reaching the glycemic target. So that's the end of the chi-square. When you have done that, and with that interpretation that I have made, I think we have well understood. So we have seen that at 6 months, more patients in the drug group, that is 52 over 75, that is around 69.3% versus the placebo 18.7%. So we said that at 6 months, patients in the drug group achieved HbA1c less than 7 That is compared to placebo. I think that one is well understood. So you can close that analysis also. So next we go to so what question in our questions which we had which we had, that is let me bring back the questions which we are trying to answer. So here the question number 4. Did more patients reach treatment targets? So HB1C less than 7. So you have seen. So patient, here you can now confidently say that patients who are in the drug group achieved the HB1C 7%, that are 7, less than 7, I mean. Sorry, less than 7. So also you can check when you want to check for the blood pressure. Also you can check for the weight loss. I think you can use the same. You can use the same procedure you have used. So the next thing we want to check is which factors predicted better outcomes. We want to check which factors predicted better outcomes. So for this one now, after carrying on the chi-square, let's now get to logistic regression. The logistic regression now will tell us which factors, for example, is it the age, is it the sex, is it the adherence, or any other factor that we end with us. So we get how to carry the logistic regression. First of all, we get to you go to analyze. You go to analyze. You go to regression. When you get to regression, you get to the binary logistics. I think anyone who have SPSS is following. You get the binary logistics. So here now you have to choose the dependent variables, which our independent variable here now is our HB1C target after 6 months, which we had recorded. So this one you bring in to the dependent variable. So the covariance is now there. We want to check, let's say, for example, the group, that is this one now is the drug and the placebo. We bring it in here. So also we bring in, let's say, for example, age. We can bring in, so if we want to get some more factors which we want to bring in, let's say, for example, let's say, for example, weight or the BP baseline, we'll just have to go back and record. So let's go back and so that because when you, let's say, for example, I try to put in weight baseline, another covariate. So you come here to categorical, so the categorical variable we have here is only the drug, that is the placebo, and the placebo and the drug. So we can ensure that we get some more. Or you can just carry it on the way it is. So continue. Let's see. So we just enter. So the logistic regression of our data have been carried. So this one now is the summary of your data. So we have included in analysis, we have 150. We have the missing case 1. We have a total of 151. We have the independent variables, categorical coding. So the most important here is the variable in equation. So the variable in the equation, this is the most important because this one now is the one that we are supposed to interpret. is the one that we are supposed to interpret. So in the interpretation of this regression analysis, just a minute. So in our analysis, we'll get the horns. Let me get to the model. So you have the model, the variable in question. This one now is the model. You have the variable not in the equation. This one have not been included. That is the drag one. That is that 9 point. The score, the age and the weight baseline. So block one. So here we say that the model fit. That is the model fit. It tells us that the in reaching the HB1C, the patient, especially the ones who are under the drug, they were the ones that are under stronger. They under stronger probability. That is the probability of reaching the HB1C, reaching the target. The patient who are under drug. So overall, the model explains that the model explains that 87% of the variation in reaching the HB1C is less than 7% is very strong, especially for the patient who are under drug. That's what the model tries to tell us. So in conclusion of this model, we get that patients on drug are more likely to reach HB1C compared to placebo after adjusting for age, also for gender and baseline HB1C. So we know that not statistic each year Honda increases ons by 4%. But effect is not statistically significant. So for age, age does not have any statistical significance here. You can see the age have no statistical significance. Same to weight. But the drug have a statistical significance. So we can say that the patient were strongly the patient who are under drug were able to achieve the HB1C less than 7 compared to the patient and the placebo. And here we can conclude that drug and age, we can conclude that age, weight baseline, and weight baseline have no significant effect, especially on the patient achieving less than 7, achieving less than 7 test after the patient came to the clinic after 6 months. So that's what we wanted to see when we ran a logistic regression. So in a clinical interpretation, the drug effect, we say that even after adjusting for age, gender, and baseline HB1C, the drug group had dramatically high odds of reaching HB1C compared to placebo. That's what we can conclude about our model. So here, we can say that the patient, let's say for example, the patient and 160 horns. So for example, a patient who is under drug and 160 horns of achieving less than 7 compared to a patient who is on placebo. So patient with higher baseline HB1C and much lower odds of achieving the target also. So here we have also concluded that not statistical age and gender is not statistically significant predictors of achieving less than 7% of the HB1C. So yeah, this one now is the most important, the model. You have seen the likelihood, that is the The patient 160, this one is the horn. The one patient to 160, the patient in drug is 160 times. Is 160 times horned to achieve less than 7 compared to a placebo. So in summary, we can say that after adjusting for age, sex, and baseline, patients on the drug were over 160 times more likely to achieve HbA1c less than 7 at 6 months compared to placebo. So baseline also, HbA1c strong influences treatment. That's what we can say. Treatment success while age and gender did not influence. That is from the significance. So because the age and the because the age and gender, so here you didn't underline the gender. So because the age and the weight baseline have no significance. They have no significance. So next after that, we want to conduct our last analysis. So our next analysis that we want to conduct is a multiple regression. When you do a multiple regression, we'll have also cover under the uncover. That is HbA1c at 6 adjusted from baseline. So we want to do a multiple regression so that we'll have covered everything. We'll have covered because so first here I said that the uncover and the multiple regression will just perform the same thing. So we want to see whether the intervention effect and adjustment for covariance there's any effect. So we have to do a multiple regression. Let's do away the uncover. So let's go to multiple regression. Just a minute. So to do a multiple regression in SPSS, we'll just have to go to analyze, but we have a lot of steps that we have to follow before we do the multiple analysis, the multiple regression. There are a lot of factors that you have to key in so that we can get the correct data. So first of all, you go to analyze. Just a minute. So you go to, So you go to analyze. I think those who have an SPSS can follow. We can go to regression. We can go to linear. So we are there. So when you get here, so which is our independent? Our independent variable is the HbA1c after 6 months. HbA1c after 6 months, so it's our independent variable. So that is our the independent variable. So our independent variables now we can have the drug, the HbA1c baseline. So you can have, for example, HbA1c baseline. Also, you can have something like wait in 6 months. No. Something like drag. No. Wait 6 months. So you come here, you select, you want to fit a model fit and a model fit and estimate. Just select, you want to do a regression coefficient, model fit. So continue. Let's see the output. Okay. So you can see the output. Just a moment. So our multiple analysis here now, we can see the output. So here we have the interpretation of our analysis. Now, the multiple analysis, we know that usually refer to running multiple statistical analysis on different variables. Like for example, here we have run our the weight at 6 months, the HB1C baseline. We have just used 2, but even you can run 3, 4, 5. For example, you can, so that one, you can run more than even 4 variables in multiple regression. That's the reason it's called multiple regression. So here in this multiple regression, we want to see which variable predicts, which variable predicts a continuous outcome. So that's what a multiple regression tells us. Which variable predicts which variable predicts a continuous outcome. So in our model, we have in our model, this is our model. This is the model summary. This is the ANOVA. And these are the coefficients. These are the coefficients for the variables that we entered. So let's say, for example, multiple regression here, the overall model for, just a moment. So this one now is the F statistic, that is 151.215, and the significance is that is less than 0.001. So we have now got our model. What does our model tell us? This model now on the ANOVA, it shows that when we get to ANOVA, or ANOVA is a one-way showing significant difference in recovery, the difference between the placebo and the drug. So here we want to see this, the sum squares of we have the sum squares, that is under the regression, we have the 2.4, 4.2, we have the residuals and the degree of freedom, that is 2, that is we have a degree of freedom 2, we have here is 147, that is n, that is 150 minus 3. the mean squares, and the F statistics, and the significance. So the coefficients, these are the coefficients that are fitted in the model. So here you can conclude that there's no statistic significance that the weight affecting the drug. There's no statistical significance because it's less than 0.005. There's no statistical significance. So anytime we want to conduct a multiple regression, that is the way how to go about it. So that's how to do a multiple regression. So in our multiple regression, what question was our multiple regression answering? Let's get to our question. So here we need to see whether the intervention effect and adjustment for covariance. So you can see there's no significance. There's no significance. Here you can conclude there's no significance. After all those analyses we have done, I think we have covered all the analyses that are most important, especially when running inferential statistics. So for our study on diabetes, that is the practice example that is on diabetes control and the placebo and the drug. What conclusion can we make? Someone can type a conclusion which we have made. Someone can tell us a conclusion. Can give us a conclusion from all the analysis that we have done on our data. Someone can give us a conclusion on the comments. Someone can give us a conclusion. So from our analysis, we have seen that we have answered this question. Then the HbA1c improved over time. Yes, the HbA1c improved over time, especially on patients who are under drug compared to patients who are under placebo. So was the improvement greater in drug group? Yes, that one is we have already concluded. We have done the analysis and also we have concluded that. What about weight? Also, when we want to check whether the weight and the blood pressure increase control, whether it was controlled. Also, we have said you can run the same test we ran, that is the independent t-test. So did the more patient reach target? So also you have answered this question. The patient who are under the placebo, who are under the drug, reached the target of HbA1c less than 7 compared to patients who are under placebo. Also, this question we have answered it. So, which factor predicted HbA1c outcome? Which factor? So, from our analysis, we have seen that the age and the age weight and the age weight and weight did not have any influence in the reduction of HbA1c. That's what we have concluded. So don't mind the lower baseline HbA1c prediction success. So the intervention remains significant after an adjustment. So we have concluded after multiple analysis that the HbA1c, the intervention, the HbA1c did not remain significant after the adjustment. So overall, in our study, that is the practical. What we can conclude is that. So what we can conclude for our study is it shows that the drug significantly improve HbA1c level and the likelihood of reaching treatment target compared to placebo. So we can conclude that the drug significantly improved the HbA1c levels compared to the placebo. So that's the conclusion we can make from all the analysis that we have carried, especially on the inferential analysis that we have done. So what the inferential analysis really does is tell us on more about how the comparison of different groups, whether what you wanted to test you have achieved or you have not achieved. Whether, like for example, in our study, we can see we have achieved the HbA1c. The HbA1c reduction have been achieved, especially after six months, to patients who are under drug compared to the patients who are under placebo. So that's the end of our analysis.